Good morning, friends. Today we'll be studying structure of atom. This is the first chapter of your class 11. This chapter is having a very famous saying that is called structure of atom replicates structure of universe. Means understanding or exploring atom is like exploring universe. When you explore something, is like mostly is traveler, but in science, scientists are explorer. So this chapter is being explored through different experiments done by different scientists. The very first experiment was done by Thomson. That was the first explorer of the atom. And he did one experiment that is called cathode ray experiment. With cathode ray experiment, he discovered a very important fundamental particle of structure of atom. Atom is having three fundamental particles at your course level: electron, proton, neutron. So we'll be studying or exploring the atom with through these three experiments. The very first experiment was given by Thomson. So he was having very interesting setup. So these are the topics we'll be covering: experiments and certain observation like hydrogen spectra. To explain this, Bohr model was given, then quantum and electronic configuration. So let's dive into the very first experiment that was done by Thomson, the first explorer of chemistry. And this experiment was remarkable. He gave the very first quantity, very first quantity related to atom. He quantifies electron. He gave charge and mass ratio. He was having this setup. You can see this is on the board. He took a very simple setup. It was a glass tube. In this tube, he took two plates. One is on left side, other one is on right side. And he connected this with the battery. And the battery was having very high voltage. The battery was having very high voltage. And second condition, what he created, that was very low pressure inside this tube. He kept a gas, and when he switched on this battery, what he saw a patch of light on this side of the glass tube, and he saw a ray coming out of cathode ray and falling at the back of the anode. That was giving green patch, and this was the mystery he knew to explain. For that explanation, he did a further small modification in his setup. And this here you can have a clear visualization what was happening with his experiment. You can see the green patch you are seeing on this side is because of something coming out of the cathode. The moment the battery is switched on, high voltage battery is switched on, a beam is coming from cathode ray going towards anode ray and bombarding the screen. And he saw this green patch was the mystery for him to explain. Okay. So he thought of a ray, that some ray is coming from cathode side and going to anode side. We call it cathode ray. And he was not having any clue. Thus, he named it cathode ray. What are the property? He did further experiment and very simple setup he put. The first setup was that he brought two plates, opposite plates, negative and positive. You can see here clearly when there is no negative positive plate, electric plate, the beam is going straight. But the moment positive plate is brought closer to the beam, it bends toward positive plate. So one thing was clear here, that this beam consists of something charged. Okay, so he gave that this concept, this idea that cathode ray must contain a negatively charged particle. Later on, will be called as electron. This one experiment. Further, one thing, he also proved that this cathode ray travels in straight line. It doesn't travel in random direction. Okay, it travels in a straight line. Straight line. How can you check it? We know this in real life. We see a shadow in every day. With the movement of sun, we see shadow of a static object moving with the movement of the sun. That's only possible because light moves in straight line. When something falls between you and sun, you see shadow of that object. The same thing happened here. You can see here this object, plus sign object, when it was kept between cathode ray and other side of the tube, we see a shadow of this object. Right now this object, you can see the moment. Yes, now you can see its image towards you. One more thing, when you bring this bar magnet from top, the ray direction is also changing. With magnet, the ray direction of cathode ray is also changing, and when direction of beam or ray changes, shadow also changes. Its shape, its orientation, its elevation, everything changes. In real life, we know that in morning you are having different shape, size, orientation of shadow of a tree. In noon different, in afternoon different. So this is only possible because light travels in straight line. Okay, the same thing. So second very important conclusion was done by Thomson, that cathode ray, whatever consists of cathode ray, excuse me, cathode ray, that travels in straight line. So what is the established fact till now? First thing, it was negatively charged. Second thing, it was traveling in a straight line. Okay. Next thing, in fact, this experiment you can see, the scientist is bringing some, you can see it's looking like some metal strip. In fact, this is a magnet strip. When he's bringing it closer to the beam of the cathode ray, it's getting bent. So this was a reinforcement of that concept that cathode ray consists of charged particle. But it doesn't show, you cannot directly say whether it's positively or negatively. That's why these two experiments together, one was electric field and other was magnetic field. From electric field, we got that it is negatively charged, and the magnetic field is also showing that this ray indeed is having charge. Okay. Next thing, wow, very interesting. Next thing, because he was studying something, that was matter. So matter is having certain property. One of the most important property that will come to your mind is mass. Whether this, whatever constitutes cathode ray, whether it's having mass or not. It's very simple. You can understand. You need not to go into very hi-fi concept of physics. I'll give you one real life simulation here. If you are having a stone and throw it on some object, you know the impact, what kind of impact you will get or movement you will get on the other object. If you replace that stone with same size tennis ball and hit that object, what you will see? The impact is less, or movement will be less. That means force is less. Let's change again it into a ball made of paper. What will happen? The impact is almost negligible. The movement is almost negligible. If you keep on going into this extrapolation and make the mass of the object you are throwing on other object zero, what will happen? There will not be any movement, no impact. So it's very simple concept. One object hitting other object, if they're not having mass, there will not be any movement observed or any force transfer. So in this experiment, you can see this is a simple setup. There is fan-like structure, and it can rotate around its axis. It is having bearing setup just like fan in your house, and this blade, this blade, okay, and this is axis. When it is static, when you switch on the battery, cathode ray is heating. After switching on the battery, what Thomson saw, there was deflection in the flap of the fan. And this is not possible unless until the cathode ray is having, the particle inside cathode ray is having mass. So this is a very big, it's not a small thing. Before this, chemistry was jadoo, magic. At this point, he was able to say something, quantifying something inside the atom. Believe, just focus here, that this particle, something which is coming out of the atom, is having mass. Okay, so naturally, So far, he was able to establish it is having charge particle and negatively charged particle, and it is moving in straight line. And third, it is having mass. Okay, so these three properties, friends, students, so far we discussed, these are the behavior of the cathode ray. So far we have not measured anything related to that particle which constitute cathode ray, and this was remarkable. Whatever here I have written specific charge. Specific charge is nothing but charge divided by mass. So Thomson was successful in calculating charge on electron and its ratio with its mass, which is called specific charge. And the remarkable thing was that he calculated correct value. Okay, and that's how comes out to be around 1.7 into 10 power 11 coulomb per kg. And this property was independent of the gas taken inside the discharge tube. This property was independent of the gas taken inside the discharge tube. Means if you are taking hydrogen inside the discharge tube, you are taking lithium gas inside the discharge tube, you are taking hydrogen gas inside the discharge tube, this ratio was fixed. So from here he concluded that the specific charge of cathode ray is independent, and you must remember this, independent of the gas taken inside the discharge tube, taken inside discharge tube. Discharge tube is nothing but that glass tube inside which Thomson performed his experiment, put two electrodes, negative and positive, cathode and anode. Negative he called a cathode, positive he called anode. Positive cathode was connected to the negative terminal of the battery, positive, and anode was connected to the positive terminal. So this point was very important, and you will get a very frequent question on these 4 points, and we'll be summarizing this. First point, what we'll understand. First thing, what experiment we did, that it is negatively charged particles. Okay. Second, first, the cathode ray consists of negatively charged particle. Second, it moves in a straight line. Okay, in a straight line. Third, the most important thing, it is having mass. Fourth, the specific charge calculation. Specific charge calculation. Believe me, this seems very trivial, very simple, but every year you will be getting questions, one-liner, two-liner questions, or objective questions based on this. So why wait? Let's do some questions on this. Okay. See this question. Cathode ray travels in, fill in the blanks, from cathode to anode in absence of electric or magnetic field. What should be the answer? Parabolic path? No. Parabolic path, circular path? No. It was a straight line. So, and it is directly from the observation of cathode ray experiment or Thomson experiment. So, answer is C here. Next question. Wow. Which of the following statement is true for cathode ray? It is not deflected by magnetic field. Oh, what are you saying? Yeah. It is deflected by magnetic field. We just saw scientists how is deflecting that green beam. It does not travel in a straight line. Wow. This is a very one most important observation or experiment done by Thomson. So it does travel in a straight line. It is not deflected by electric field. That's also wrong. It consists of only negatively charged particle. This is correct. So this is true for cathode ray. Option D, definitely, no doubt, no hesitation, D is correct. Okay. Next question. It was concluded from the cathode ray discharge tube experiment that mass of an electron is fractional. No, we didn't discuss this. We never discussed this. I told you only one quantity Thomson measured, that was what? Charge by mass ratio. He was never talked about individual charge, individual mass on electron. To let it be clear, Thomson never calculated charge on electron or mass on electron. He calculated their ratio, and we'll be seeing, we'll be exploring further how the charge of electron and mass of electron was determined. Another story of very beautiful story, interesting story, Milken's experiment. We'll be seeing next one. Okay. Option B, matter contains electron. Yes, if matter doesn't contain electron, from where it is coming out? It's not jadoo, it's not alchemy of old days. So option B definitely is our correct answer. Matter contains nucleus. Yes, contains matter, atom. Atom contains nucleus, but it was not domain of Thomson's experiment. It was, we'll be seeing another exploration of atom through scientist Rutherford. These are our explorers. Okay, we'll be calling them explorers, scientists, science explorers. So Rutherford, the explorer, he explored the nucleus. He further explored the atom and entered into the nucleus. So this was not domain decided by Thomson. Okay, so based on this experiment, Thomson gave one model that we laugh around, but still is there in your books, in every textbook. The very first model we study, and when we see, we laugh. What kind of model? Let's see why is we still. The point is that when we laugh on this model, why is still there in the book? Okay, that means it is very important. Something it still explains. That's why it's relevant and it's there. Okay, and you cannot criticize. Believe me, you cannot criticize on that the point on which it stands today. So this is a plum pudding model, because electron was coming out of atom, and Thomson must have thought about plum pudding or watermelon kind of things. Okay, this, for example, if you take a watermelon, the red part, he considered that it is a continuous positive charge, and the seeds, backside seeds, they are embedded inside that red part. He called them electron. Same way in plum pudding, the continuous part, the cake part, you can say that positive, and the cherry embedded was negatively charged. So we know today that atom structure is not this simple. It's laughable, but why are still studying, and why it's there in the book? The reason is it's still successfully explained why atom is neutral, though it is having a charged particle. And before Thomson, it was a puzzle to explain. Before Thomson, there was only one real life experiment. When you rub glass rod with certain wool, two glass rod with certain wool, and you bring two glass rod together, they repel each other. And that's only possible when there is charge. So this was a puzzle, and people used to think it's a magic. So this a mystery was solved by Thomson. Thomson said, no, bhai, there is a negatively charged particle. And when we rub it, that negatively charged particle comes on this rod. And because two rods have been rubbed with the same cloth or cotton, cat skin, so it's getting electron on both, negative charge, and they are repelling each other. So he was successful. He successfully explained that. On this, you cannot criticize. He never explained spectra. He never explained quantum model, nothing. So if you want to criticize Thomson model, you can criticize on this basis. The concept he tried to explain, the mystery he tried to explain, and the mystery was that why atom is still neutral, though it is giving charged particle. Okay, so we'll be exploring the atom, universe of atom through more experiment. Be tuned, a lot is coming. It's not. See you. Bye bye, friends.